a good sandwich.
The ball has momentum, a property of mass and velocity. The total momentum in a system is conserved, so when the ball collides with the first book, a certain amount of momentum from the ball is transferred to the book. This gives the book velocity, which then collides with the next book. The ball at the end of this line of books is knocked down the ramp with a small initial velocity, but it has gravitational potential energy. Energy is also conserved in a system, and it exists here in two forms, kinetic and potential. In the ramp scenario, the gravitational potential energy of the ball is being converted to kinetic energy, which is another mass-velocity relationship. This conservation of energy allows the ball to gain more velocity.
The ball's velocity is not significantly affected when rolling across the chair's surface, as objects in motion stay in motion until affected by an outside force, which in this case is a very small friction force. The contact force of the ball colliding with the books causes the book to accelerate off the chair, while the ball is reflected backwards with equal force. The book falls onto a string, which applies a tension force to another book, knocking it over. That other book applies a tension force onto a simple lever, which gets rid of the object obstructing the zip line. A carabinered object slides down the zip line due to the force of gravity, which eventually knocks into a bag of marbles. The marbles fall down into a bucket of water, pushing down red solo cups, which apply a tension force to another book. That book pulls down a ball of rubber bands, which is acting as a counterweight to the pulley connected to the scissors. The rubber ball pulling down on the string pulls upwards on the scissors, which allows it to cut the sandwich.
Wow, that's amazing!